Hello everyone. This is a video that you might be Heathkit users and VEX users might be interested in. It uses both the Hero 1 robot and the VEX Cortex to upgrade it to be able to make it do new functions that it could not do in the past. This takes a normally working Hero 1 robot and upgrades it so that you can teach it various movements using a VEX game controller. In the previous video, I described how you could use a teaching pendant emulator to allow you to use the VEX game controller to control your Hero 1 remotely with VEXNet, which is a form of internet or Wi-Fi. Using the VEX Cortex shown here that's running the motion script generator firmware that I wrote in Robot C. The important thing is to use the schematics that I provide in my article for the correct wiring. It's critical that you make the correct connections, otherwise you could short out one of the circuits. The teaching pendant did use 5 volts, but the VEX Cortex doesn't require that 5 volts wire. It just requires the signals coming from the digital outputs of the digital inputs of the Hero 1 robot's teaching pendant, as shown in the schematics that I provide in my article. In the previous video, I showed you how you could connect the VEX Cortex to the teaching pendant port in back of the Hero 1 robot shown here. You can see the cables, the jumper cables leading to the back of the robot. That bottom plug is a 15-pin Molex plug that normally connects the black teaching pendant provided originally by Heathkit. We can now use the motion script generator to make the Hero 1 robot move around move its arm in different positions and its head in different positions, and then we can record them using the record function or the record button on the VEX game controller. Basically what the motion script generator does is it records all these commands to a file using an application on a PC or laptop called TerraTerm. And TerraTerm can read in serial data and log it to a file. And the file that we're logging it to is the motion script file that we will use later so that we can play back the motion to the Hero 1 robot and then have it act out all the commands that were previously recorded. Heathkit originally provided a similar function using its teaching pendant and using its learn mode, where you press 4 or you press 7 on the hex keypad, and then you gave it an address of memory where you wanted to store the recording or later play it back, and then you had to give it the address of where to start playing back the motion script. Unfortunately, memory was very limited at the time, and you couldn't play very long motion scripts. My goal is to be able to have the Hero 1 play a game of chess with me, or play cards, like blackjack, and those require a lot of movements and different types of movements, and you'd very rapidly run out of memory with the original Hero 1 teaching pendant. But what I've done is I've allowed very large motion script files to be written right now just using TerraTerm, which works very well for this application initially. It does have some limitations that I'll talk about later, but for now, just to be able to record motions generally and be able to play them back, they won't be played back exactly in the same timing sequence at this time. That will require future software that I'll describe in the next installment. But right now it'll play them back pretty close. So you could train it to move a piece and it'll move the piece. It might move it slightly faster or slightly slower. That's one of the limitations I'm talking about. Still, it's pretty amazing that you can do all these features using the original Heathkit electronics and the original 6808 microprocessor that Heathkit designed the system, all the electronics around. The 6808 is actually moving all the motors even now with this upgrade. The upgrade just basically takes over the teaching pendant and it fakes it out into thinking that the VEX Cortex is a teaching pendant. And what that allows you to do is it allows you to load much larger motion scripts like I'm doing now, and it'll allow you to play them back also, so that you'll be able to do very complicated movements or choreography if you want. Here's the VEX game controller that we're going to be using to show you how I record motions from the robot. I use all the same function buttons and the two joysticks the same way I did as last time with the Teaching Pendant emulator. And all those motions now get converted to command bytes that are then sent via the serial interface to the PC or laptop running TerraTerm. And TerraTerm takes these command bytes and saves them to a log file. The log file I call right now, I'm up to is motion7.dat. Okay, I'm going to turn it on now.
Ready.
You hear it say ready when you power it up. And then I'm going to press on the keypad 3-1, which is means to home all the motors. Right now I have the robot blocked up, so it's not going to move around. For this demo, I don't need to have the robot moving around. But it can move. In fact, you can train it to move backwards and forwards also. I'm not going to do that at this time. So here goes, 3-1. I just pressed 3-1 to home the Hero 1. And you'll see it go through its homing algorithms. So you need to do this when you're doing it with the original Teaching Pendant. You had to home the robot too to play back motion scripts. And you have to do it now with the VEX Cortex also, the motion script generator. There you see it's going to turn the head till it hits both limit switches, the clockwise and counterclockwise limit switch. And that's pretty precise movement using the stepper motors and geared motor that it has. Now it's homing the steering wheel. And there it's going to home the wrist rotate and wrist pivot. And it closed the gripper.
Ready.
So it completed the home position. The next step is I'm going to play back a motion script, motion 7 that I previously recorded. I'm going to do that right now. Okay, I'm about to play back the motion script. I'm using TerraTerm.
Ready.
In order to actually play back the motion script, I have to press the learn mode on the Hero 1 robot. I'm not going to use the 7, I'm going to use 4. Which is actually the Teaching Pendant mode versus the Learn mode, which is actually 7. So I'm going to hit the command 4 on the keypad. Which I just did. Now I'm going to send the command file, the motion script file, to it. Okay, there you see it moving clockwise, counterclockwise. And these are commands that I previously recorded using the game controller. Clockwise again. Okay, now it's going to rotate the wrist. It's going to open and close the grippers. It's going to turn the steering left and right. And since I don't have the robot on the actual floor, the motor, the main drive on the floor, it's just blocked up, because otherwise I would rip away all the cables that I have hooked up to it right now. Normally, well, now it's going backwards. You can hear the squeak when it goes backwards. Now it's going forwards. So the robot, if it wasn't blocked up, would be going backwards and forwards and turning left and right, moving around your room. Again, this is the motion7.dat file that I recorded previously, just showing a different angle. This is TerraTerm. In the background is the Robot C environment, the Robot C IDE running the application with debugging. But normally you wouldn't see that. That's all embedded into the controller itself. I'm just having it here just for debugging purposes. But basically you'd use the send file on TerraTerm. And then what you would see when you run it is the following. This menu would pop up. It's called a TerraTerm Send File panel, and it lists all the motion scripts that I've previously recorded using the game controller. I showed you recording all of these the last time. When I was moving the robot around, it was writing all these motion scripts. And I took the last one, and that's what I'm using to show you how you can actually play the motion script here. So you use TerraTerm to both record motion scripts and to play them back. When you record them, you basically just go to the log file, and it creates a motion script there for you. But when you play it back, you have to select from one of the previously recorded motion scripts, and then you tell it to send that file, and it'll send it over the serial link to the Hero 1 robot. And right now it's sending it at 19.2 baud. Even though I recorded it at 115/200, I'm playing it back at 19.2 because if you play it back too fast, the VEX Cortex doesn't have enough time to respond, and then it starts losing data. Alright, I just selected Motion 7, and I'm going to click on the Open button, and that should get it started. And then on the screen you'll see all the commands that are being sent to the Hero 1 robot to make it move. And there you see that the commands being streamed to the Hero 1 robot. And these are interpreted by the motion script generator in the play mode and sent to all the motors. And the way it does that is it just uses the Teaching Pendant interface that I talked about in the previous video. It does all the same control signals and emulates the black Teaching Pendant. And that's what these commands are. This like A5, B5. It's a single byte command. The 4-digit hex number is the actual execution time that it took in milliseconds. And we'll be using that in a future video to play back motion scripts synchronized. This right now is not really truly synchronized. In order to synchronize it, I have to use a Raspberry Pi 4 application that I'll talk about in a future video. So there you see that it's okay. It stopped. That was the last instruction that it read. So until next time, fellow Heathkit users and even VEX users, please watch for my new videos on YouTube and subscribe to them. And if you like the video, please check the like button I can always use that. And I will be posting on the videos themselves the links to all the parts that you need. I haven't done that yet, but I'm going to do that in the next few videos of where you can find the upgrade kit for these different configurations.